Hi! When I learned set theory, there was a set that was difficult to understand. It was an empty set, because it was introduced as one of a set even though it has no elements. But now, I completely agree that there must be an empty set. Although it contains nothing, the empty set makes set theory a complete theory that includes everything. Let's math travel. A is the set of even numbers, and B is the set of odd numbers. What is the intersection of A and B? Oh no, there is no such element. It is impossible for a number to be both even and odd. It is difficult to define this intersection. U is the universal set in which all natural numbers are elements. There are no other elements. Then, what is the complement of U, which is a set that does not belong to this U? There are no elements. It is hard to define this complement of the universal set. P is the set of natural numbers less than 10. Q is also a set of natural numbers less than 10. What is the different set, which is the set of P minus Q? Since P and Q are the same set, there are no elements in the different set P minus Q. In this case, defining the different set is also ambiguous. There are no elements in the intersection of A and B, the complement of the universal set U, and the different set of P and Q. What would you say the answer is? It is one of two things. You can either exclude such cases by saying that there is no answer, or define the empty set and call the answer the empty set. Which option would you choose? If you don't want the math to expand, you might choose to exclude such cases without hesitation. What about math? Mathematics always wants the mathematical universe to expand. So, mathematics decided to define the empty set and include the cases with no elements as a set. It is attributed to be the work of mathematician Cantor. It seems quite reasonable to say that the empty set is not a set. What is a set? It is a collection of different objects. The objects are well defined and satisfy certain conditions. It looks like a set must have at least one element, like the set of prime numbers less than 20, or the set of people who look just like me. But it is much better to define and use the empty set as one of a set. To whom? To math. The empty set is like zero in numbers or imaginary root in equations. It was the operation that led to the invention of zero and imaginary root. Zero was designed to represent the answer to operations such as 2 minus 2. Imaginary root was introduced to express the answer of equations such as x squared plus 1 equals 0. The empty set also appeared to make the operations of sets more free. As a result, set theory became more complete and the scope of mathematical thinking expanded further. Just as zero and imaginary root are natural, the empty set is also natural. It's time for our brains to get used to this empty set. Welcome, empty set. Welcome you.